So today we're going to look at dividing decimals. Before we do, though, I have a little activity I'd like for you to do. I would like for you to use a calculator to solve each of these problems, get the answers, and then once you've done that, start to kind of look at the answers, look at the problems, and see if you see some connections that might explain what it is that you're looking at. Once you're finished with that, go ahead and advance the video. All right, now that you've done that, you've hopefully noticed that each of these has an answer of 3. And there's a reason for that. They all have the same answer because they are all essentially the same problem. Let me show you what I mean by that. We know that 240 divided by 80 is equal to 3, and so is 24 divided by 8, so that means those two problems must be equal to each other. Well, when you look at this, the trick is really look at the decimals in the problem, and if you'll notice, if I move both decimals to the left, I end up with the problem 24 divided by 8. So let's look at another example then. If I look at 2,400 divided by 800, which is 3, that has to equal 24 divided by 8, which is also 3. So again, if we look at the decimals, notice the decimal in 2400 is here. The decimal in 800 is here. If I want to make this problem look like 24 divided by 8, I have to move both decimals 2 places to the left. Let's look at a couple more problems. If I look at 2 and 4 tenths divided by 8 tenths, notice we know it's equal to 24 divided by 8 because they both have 3 as an answer. And if I look at the 2 and 4 tenths divided by 8 tenths, if I moved both of those decimals 1 place to the right, I would get 24 divided by 8. Let's look at one more example. In our last example, 2 and 4 tenths, or 24 hundredths rather, divided by 8 hundredths is 3, which means it's also equal to 24 divided by 8, which is also 3. Notice in 24 hundredths, if I move the decimal 2 places to the right, and I do the same thing to 8 hundredths, I get the problem 24 divided by 8. So hopefully what you're seeing here is that as long as you move the decimal the same number of places in both the dividend and in the divisor, the quotient stays the same. So you can make the problem simpler perhaps by moving the decimals as long as you move both decimals the same number of places. Now if you look at another set of problems that looks the same, you're going to notice those don't all have the same answer as the 24 divided by 8. And here's why. If you look at 240 divided by 8, it does not equal 24 divided by 8 because 240 divided by 8 is 30, but 24 divided by 8 is 3. Well, take a look. If we had tried to make 240 divided by 8 look like 24 divided by 8, notice I was only moving the decimal in the 240 once to the left, but doing nothing to the 8. So the two problems are not equal because I didn't do the same thing to both decimals. I can look at each of these problems and see that that's the case, that I'm not doing the same thing to both decimals, which is why those two problems are not equal. They don't have the same answer. Oops, let's make that an 8. All right. So again, 24 is 24, but here for the 80, I would have to move 1 to the left. That's not moving the decimals both the same way. 2 and 4 tenths divided by 8 hundredths does not equal 24 divided by 8 because 2 and 4 tenths divided by 8 is 30. 24 divided by 8, of course, is 3. So looking at the decimals, I would have to move the decimal once in 2 and 4 tenths to make it 24, but twice to the right in 8 hundredths to make it 24. It's not a match, so the answers are not the same. 24 divided by 8 hundredths does not equal 24 divided by 8 because if I look at the decimals, I don't have to move this one at all, but this one would have to move, the 1 in 8 hundredths would have to move twice to match the 8. So notice if I do not move the decimals the same number of places in both numbers, then both the dividend and the divisor, then my quotient does change. And it still has the 3 in it, but the place where the 3 is changes, which changes the value of the answer. So let's look at what we actually need to do. Here are your directions for dividing decimals. Go ahead and pause for a moment and copy those down. All right, now that you've copied those, let's take a quick peek. The directions say make the divisor a whole number. Whole numbers are always going to be easier to divide by because we can do multiples of those pretty easily. And then the way we do that is by our moving the decimal. Remember, we're going to have to move both decimals the same number of places. Then I bring the decimal straight up in my quotient and I divide just like I always would, but I might need to annex a decimal or zeros. We'll look at some examples. The first problem, 75 hundredths divided by 5. 75 hundredths goes in the house, 5 goes outside of the house. And I'm ready to divide because guess what? My divisor is already a whole number. It's 5. That's a whole number. So my decimal comes straight up. 5 doesn't go into 0. It goes into 7 once. 1 times 5 is 5. 7 minus 5 is 5. Or is 2, rather. 2 is less than 5, so I can bring down this 5. And 5 goes into 25 5 times. 5 times 5 is 25. And I'm going to get 0 when I subtract. That problem is done. 75 hundredths divided by 5 is 15 hundredths. Next problem that we'll look at. 3 and 33 hundredths divided by 6. Again, 3 and 33 hundredths goes inside the house, 6 goes outside. My divisor's a whole number, so I just bring up the decimal and then divide. 6 will not go into 3, it'll go into 33 5 times. 5 times 6 is 30. I subtract and get 3. 3 is less than 6, so I bring down the other 3. 6 goes into 33 5 times. 5 times 6 is 30. I subtract and get 3. Instead of getting a remainder here, I'm going to annex a 0, which doesn't change the value of my 3 and 33 hundredths, and bring down that 0. 6 goes into 30 5 times. 5 times 6 is 30. When I subtract, I get 0, and I'm now done. If it hadn't worked out, though, I could have annexed another 0 to keep on going. Here's another example. 3 and 6 tenths divided by 4 hundredths. So 3 and 6 tenths divided by 4 hundredths. This time, my divisor is not a whole number, so I need to make it 1. I need to make it 1 by moving the decimal 2 places to the right. And so I need to move my other decimal, the one in the dividend, also 2 places to the right. Remember, whatever I do to the divisor, I'm going to also do to the dividend. That's very important. So then I rewrite my problem, which is also very important. I'm going to get then 360 divided by 4. When I work this out, 9 goes into 36, 4 goes into 36 9 times rather. 9 times 4 is 36. And I'm going to bring down this 0 after I subtract. 9 goes into 0 0 times. 0 times 4 is 0. 0 minus 0 is 0. And it is important that I do that, that I put that last 0 in the answer, because here's my decimal. If I hadn't put that last 0 in the quotient, or if I hadn't put the 0 in the quotient, I really can't have 9 and then an open place value position and then a decimal. That doesn't work. Sorry about that. Let's go ahead and go on from there. Our next example is 2 and 52 hundredths divided by 8 tenths. And so I'm going to put the 2 and 52 hundredths in the house and the 8 tenths outside of the house. I am going to have to move the decimal. The number on the outside, the divisor, is the boss. That's the one that decides how many places to move the decimal. It says I need to move 1 place so my divisor can be 8, which means the decimal inside the dividend has to also move 1 place. It is okay to have a decimal in your dividend as long as your divisor is a whole number. Decimal comes straight up, and I can start dividing. 8 won't go into 2, it goes into 25 3 times. 3 times 8 is 24. When I subtract, I'll get 1, which is less than 8, so I bring down the 2. 8 goes into 12 once. 1 times 8 is 8. 12 minus 8 is 4. 4 is less than 8, so I'm going to annex and bring down a 0 so I can continue dividing. 8 goes into 45 times. 5 times 8 is 40, and I am done. So 2 and 52 hundredths divided by 8 tenths is 3 and 15 hundredths. Next problem, 84 and 3 tenths divided by 12 hundredths. So if I look at this one, 84 and 3/10 goes in the house. 12 hundredths goes outside of the house. I'm going to move my decimal 2 places to the right this time for each of them because that'll make my divisor 12. And then, because I had to move twice on the outside, I do twice for the dividend. And I'm going to get 8,430. Remember, I generally try to put a decimal at the end of the whole number. That way, if I annex zeros, I don't forget where my decimal was. So 12 will not go into 8. It goes into 84 7 times. 7 times 12 is 84. I'm going to subtract and get 0. The 3 comes down, and 12 goes into 3 0 times. 0 times 12 is 0. 3 minus 0 is 3. And it would have been okay then. Now I can bring down 0. It would have been okay to do bring down the 3 and the 0 both in the same line. However, if you do that, you have to remember to put a 0 in your quotient to reflect the fact that you did that. 12 goes into 30 twice. 2 times 12 is 24. 30 minus 24 is 6. Check. 6 is less than 12. Annex a 0 and bring it down. 12 goes into 60 5 times. 5 times 12 is 60. And we are done with that problem. Now, everything we've looked at so far has worked out evenly, and those are called terminating decimals. Those are problems where the division does work out evenly. And sometimes you might have to annex zeros. That's okay, but it did eventually work out evenly. But there are times that no matter what, no matter how many zeros you annex, it's never, ever, ever, ever going to work out evenly. Those are called non-terminating decimals because they don't terminate. In other words, the division doesn't work out evenly. Within that category of non-terminating decimals, we do have another special category that's called a repeating decimal. A repeating decimal is a non-terminating decimal, but it's a decimal where the division doesn't work out evenly, but it does have a pattern. And when we see that, we use bar notation to show that. So here's an example of that. 2 and 2/10 divided by 6. 2 and 2/10 divided by 6. If I do 2 and 2/10 divided by 6, notice my divisor is a whole number, so I'm going to just go ahead and bring the decimal up. 6 will not go into 2. It goes into 22 3 times. 3 times 22 is 18. 22 minus 18 is 4. Check. Is 4 less than 6? Yes, it is. So I'm going to annex a 0 and bring it down. 6 goes into 40. 6 goes into 40 6 times. 6 times 6 is 36. 40 minus 36 is 4. I annex another 0 and bring it down, and I'm starting to notice something. 6 goes into 40 6 times. 6 times 6 is 36. And notice I could keep going forever, and I'm still going to keep getting that same pattern of having 4 left over, bringing down a 0, and then 6 going into 40 6 times. So notice here what I have repeating in the problem. Since I have one subtraction that keeps on repeating over and over, that means I have one number in my quotient that keeps on repeating over and over. So the way I'm going to write this is that 2 and 2/10 divided by 6 is equal to 36 hundredths, but I put a bar over the 6 to show that that 6 really actually keeps on repeating over and over and over again. If I look at another problem, 28 and 9/10 divided by 11 hundredths. Looking at this one, this time I have to move my decimals because my divisor is not a whole number. That gives me 2,890, and I'm going to divide it by 11. Remember to put a decimal over here so that you remember where your decimal is. 11 doesn't go into 2. It goes into 28 twice. 2 times 11 is 22. 28 minus 22 is 6. 6 is less than 11, so bring down the 9. 11 goes into 69 6 times. 6 times 11 is 66. I'll subtract and get 3. Bring down the 0. 11 goes into 30 twice. 2 times 11 is 22. 30 minus 22 is 8. I will annex and bring down a 0. 11 goes into 80 7 times. 7 times 8 is 77. When I subtract, I'm going to get a 3. So I annex, bring down a 0. 11 goes into 30 twice. 2 times 11 is 22. 30 minus 22 is 8. I'm going to subtract, I'm going to annex one more 0. And as I get here, I'm going to notice that I could continue going, but I'm still going to continue getting the same pattern over and over. I'm going to continue getting 30 minus 22 followed by 80 minus 77. 30 minus 22 followed by 80 minus 77. So since there's two subtractions that are repeating, two subtractions in that pattern that keep repeating, that means there's two numbers in my quotient that keep repeating. So I'm going to look and I see, oh, it's the 7 and the 2 that keep repeating. Notice I cannot put bar notation in front of a decimal. It doesn't make sense that numbers before a decimal keep going on and on forever. It's only numbers after a decimal that can have bar notation. So for this one, I'm going to write 262 and 72 hundredths with a bar over both the 7 and the 2 because they're both repeating in just one after the other. 7, 2, 7, 2, 7, 2, so forth and so forth and so on. And it would keep on going like that forever and ever and ever. And that gives you a pretty good wrap-up of dividing decimals. And hopefully, once you've looked at this, you have a pretty good idea of what to do no matter what kind of decimal problem you come up against. Now, I will say if you come up against a problem that is a non-terminating decimal, and it's also not a repeating decimal, then I would generally say the best thing to do is work it out to about the thousandths place, and then just round your quotient to the nearest hundredth. And that way, you'll get a pretty close answer without necessarily having to keep on going. Your other option would be to, instead of getting a decimal answer, you could get a mixed number answer. Thanks for listening and hope it helped.